Welcome back, friends. In today's session, we are going to understand the min heap and max heap. Both are heap is a very important data structure from the perspective of Java interviews, because on the coding side as well as on whiteboard sessions, sometimes you get questions that can be very easily solved if you have a knowledge and understanding of a min heap and max heap data structure. So this is here I am showing you first example of what is a min heap and max heap. So as you can see in the min heap, we always see that the minimum element in the tree will be on the top, right? So for example, here 10 is the minimum element in this whole tree. Then if you look at this subtree, then 15 is minimum element. So 15 is minimum, then 40 and 50, right? Here 30 is minimum, then 140. So this is called as a min heap. So minimum element will be on the top always in the min heap. So opposite to the min heap, there is another structure called as max heap, right? In max heap, the maximum element will be on the top of the heap always, right? So as you can see, 100 is the maximum element, it is on the top. In this subtree, if you see 40 is the maximum, it is more than 10 and 15. Here 50 is maximum, 50 is greater than or equal to 50 and 40, right? So it is on the top here. So this is basically min heap and max heap. And now one question might be coming into your mind is where we can use this, right? What is the use of this, and in Java where and how we can use this, right? Min heap and max heap. So I'm just going to quickly show you a class actually that is implementing the min heap and max heap data structure. So please look it into this java.util PriorityQueue class. This is actually implementing the min heap and max heap in Java. So as you can read here, uh, it says that is unbounded priority queue based on priority heap, right? The elements of the priority queue are ordered according to their natural ordering or by a comparator provided at queue construction time, right? So either you can use the natural ordering of the elements that you are using in the priority queue, or when you are creating a priority queue, when you are defining, you can provide a comparator, right? That will be used accordingly and to hold the element, right? So you can define it. So I will show you one example, then you will come to understand. So for example, let's say we have one Java class called as employee, and it has a 4 fields, right? ID, first name, last name, and salary. So we have getters and setters. We have a hash code and equals method implemented for this class. So if you look at the this is one example that I will show you first. So here we have created 6 employee objects here. So as you can see, E1, E2, E3, E4, E5, E6, and it has a salary field also, right? So we are actually defining a priority queue of employee. So this is a queue, or this is a heap basically, which is holding employee objects. But how do we want to order these employee objects in the priority queue? So this is how we are providing the comparator, right? So we are saying that b dot salary minus a dot salary. It means that the salary, we are going to use salary field in a decreasing order, right? So highest salary will come first basically. So let us just add this all these E1 to E6 in the priority queue, and then we will loop through the priority queue, and we will poll out all the elements one by one. So I can show you how they look like when we are polling out. Polling means we are taking out from the priority queue basically, right? So that's what polling means. So as you can see, when we are polling the elements, it starts with the highest salary, right? As you can see, this is 80,000, so it is the highest, then 44,000, then 40,000, then 24,000, then 20,000, and 10,000. So it is ordered into the decreasing order of the salary. So why? Because we have given the comparator like this. So now if you want increasing order of the salary, you can just change a dot salary minus b dot salary, and we will rerun, and I can show you that it is now in it will be in the increasing order. So as you can see now, the when you are polling employees from the queue, they are in the increasing order. So 10,000, 20,000, 24,000, 40,000, 44,000, and 80,000. So they are in the increasing order of the salary, right? So this is how the priority queue works. So this is basically a min heap or max heap. You can use it as a either of them. It depends on your comparator, right? How you are passing the comparator. So you want the minimum value on the top or you want the maximum value on the top. It depends on the comparator that you provide here in the priority queue, right? So similarly, I can give you one other example of a priority queue, like let's say we have a transaction class, right? So transaction class, we have three fields: ID, amount, and details, right? So transaction means you are buying something, so you are making a transaction, right? That kind of transaction. And these are just getters and setters for the transaction, and I implemented two strings because I want to display it in system.out.println. So I will show you how the priority queue can be used in processing transactions, right? So here we created 6 different transactions. So first transaction is like buying a cell phone, right? Bought washing machine is second, third is headphone, second is petrol expenses, next is grocery shopping, and next is medical expenses. And these are the expenses, means this is the amount that is caused in the transaction, right? So this is by mistake it happened, but this is actually the ID, right? The first field is the ID. So now we have defined a priority queue here based on the amount, and it is in decreasing order, right? As you can see, b dot get amount minus a dot get amount means the amount is in decreasing order. So we added the T1 to T6 all the transaction in priority queue, and the queue will have the transactions listed by the amount field, right? Amount will be maximum in the beginning and it will be decreasing, right? When we are polling, actually when we are polling transaction here, we can just do while the queue is not empty, PQ has some elements, we will poll the transaction and we will print the transaction here, right? So let me just show you that. So when we are printing the transaction, as you can see, the amount we are putting is in decreasing order. So maximum is it on the top 28,000, then 8,000, then again 8,000, 4,000, 500, and 200, right? So that is in decreasing order. So this is basically a max heap, right? The max heap, why? Because the maximum is on the top. Now let's put a min heap. Now let's convert it into min heap. Min heap will put the minimum amount on the top always. So for that we have to just say get a dot get amount minus b dot get amount, right? Then it will, what it will do is it will be a min heap now. So let us again rerun this example. So now as you can see here, the minimum is always on top. So 200, after that 500, after that 4,000, then 8,000, 8,000, and 28,000. So this is an example of min heap, because you are all, let's say you always want the minimum expense on the top. So in that case you can use a priority queue transactions like this basically, right? So this is the example of a min heap and max heap, how you can use the priority queues. And let's say one other example, let's say this is also one thing I want to mention is when you are solving Leetcode problems, please try to understand the priority queue first with a few examples, because some of the examples can be very easily solved with the help of priority queue or min max heap. So whenever we say min heap and max heap in the Java world, you can use a priority queue implementation. It is already provided to us as I shown you here. So you don't have to implement it. You can just use this priority queue class. It has a poll method as and a pick method. So I will show you. So poll means it will retrieve and remove the top element basically from the queue, right? Retrieve and remove. And pick means if you just want to look into what is the top element, you can just use pick. It will not remove the element, it will just show you what is on the top, right? And add means it will add your element into the queue. So just take a look into this documentation and try to understand this little bit in details. So one other example let's take to understand how the priority queue works here. So as you can say, if we have been given like a sentence, right, of words, and we want to display sentence based on its length, right? Like the words we should display based on the length, and the shortest word should be on the top. For example, on is the shortest length, right? In this, then it should be on the top. Then and is the shortest length, then it should be on the top, right? So our first this part in the example, let's just run and I'll show you the first part first. So as you can see here, let's see, right? So on is on the first, then and is there, then code, then keep, and then calm, right? Means because it is going based on the length of the word. So minimum length of the word, because we have defined the priority queue here, right? A dot length minus b dot length is the comparator, which makes is like a min heap, right? Minimum length will be on the top basically. So now let's again take use the same example, but now we will define another comparator when we are putting the elements onto the top of the priority queue. This is our another priority queue. So it will check if the both like in this case, as you can see, there are three words: keep, calm, and code, right? All are having same length. So if they have all these words have same length, then we want to use the the shortest lexicographical on the top. For example, calm is the shortest, right? Then code, and then keep, right? So that's how it should appear. So that's what we have defined here. So if they have same length, then we will just compare by using b dot compare to a, right? Compare to method we will use our string class. And otherwise, if they have this different length, we will use the minimum heap, right? A dot length minus b dot length means the minimum will be on the top if they have different length. So let's rerun this example for the second one. So as you can see, this on and so this is a minimum length, then this is a length 2, then this is length 3, and these all three have same length. So it will be going based on the lexicographical order now, right? It will compare based on the lexicographical order now. So as you can see here, so code will come first, then calm will come, and then keep will come basically, right? So that's how it will come, because we if it is the same length, it will just compare, use the string compare to method, and then it will compare that. So that is one thing I wanted to show you. So this is the way you can use the priority queue class to compare the different like objects. So I will put this code onto the GitHub my repository. You can take a look there. Try to create some kind of for example, you try to create your own Java objects, something like this transaction, and then create some dummy objects and put it into the queue, with some comparators, and try different kind of comparators here, and see how the priority queue actually handles them. So this one is based on the amount, right? So amount is there. So now let's just do one other example here. So let me just comment this, and we can change this one, the priority queue definition, and instead of that we can use, let's say we want to use a ID, right? So we want to based on the ID we want to do, right? And ID should be in descending way basically. So let us just remove this part, and we will just write our own comparator. So here a comma b, a dot get id. If we want descending, then we should say b dot get id, right? And minus a dot get id. Then it will be giving us by descending id. So let's just look it up now. So as you can see, now the IDs are descending, right? So this is a max heap basically. So maximum ID will be on the top, right? 6 5 4 3 2 1. Now if you want minimum ID on the top, then you have to just say a dot get id minus b dot get id. Then it will create a min heap, right? So let's do this again with a min heap. So as you can see, 1 2 3 4 5 6. So now this is a min heap, right? Because the minimum ID will be always on the top. So when you are falling from the queue, then the minimum will be always removed, so that's why when we are printing, the minimum will come first always, like 1, then 2, then 3, then 4, then 5, then 6, like this. So try to try a couple of examples. You will understand more about the heap, but I think I already explained you in detail. I often create Leetcode solution videos and the working sessions in Eclipse to help you guys, understand the concepts of Java and Java J2 interview help related videos. So check out my playlist. It has a lot of Leetcode examples, like solutions along with explained with the examples, as well as it has a playlist related to binary trees, binary search trees, then dynamic programming, linked list. So check it out, it has a lot of good things, so you will also learn a lot from that. So please subscribe to this channel. Subscription is really important for the channel, and it will encourage me to create more of this kind of a good content. So please subscribe. Thanks for watching the video.